Hello, I'm Mrs.Kulkarni from Balchan Institute of Technology, Solapur. Previous to this lecture, you have seen what is an operating system and features of real-time operating system. For any operating system, you need to follow some task scheduling models. So, we concentrate on real-time operating system task scheduling models. So there are various scheduling algorithms like cooperative round-robin scheduling using circular queue for ready task. In this round-robin scheduling, there is a queue of operations, process or threads where ready-to-run tasks are available. Then the total CPU time is divided into parts, so it is also called as time slicing algorithm. Another is cooperative scheduling of ready task using an ordered list as per precedence constraints. So difference between first and second algorithm is that in the second one, priority is considered to allocate the CPU time to the process. Next is cyclic scheduling with time slicing. It is also called as rate monotonic analysis, where you are identifying the critical task and you are prioritize the task and then you are allocating the CPU time. Next algorithm is preemptive scheduling, where you are preempting the task and then allocating the CPU time. Nothing but it is a cooperative scheduling algorithm. In this, each ready task cooperates to the running task. This is a time slicing algorithm which is simpler in the design and it is extremely valuable in many applications where there is no need to use the resources of embedded systems sequentially. Next is critical section service by preemptive scheduler. So in this, for servicing of a critical section, a preemptive scheduler on rising of the service need of the high priority task should not preempt the low priority task in certain cases. So difference between the third one and fourth one is that the blocking should not occur in the critical section of any lower priority task. So this is to prevent the occurrence of a shared data problem. So we will have the separate lecture for shared data problems. So in the preemptive, you are preempting the priority, but in the second case, that is critical section service by preemptive scheduler, you are not having any block for the low priority task. Next algorithm is fixed real-time scheduling, where it is also called as static real-time scheduling algorithm. Here, a scheduler is said to be using a fixed time scheduling. When the schedule is static and deterministic, then such kind of scheduling algorithm is utilized. So last one is precedence assignment in scheduling algorithm, where strategy is utilized based on earliest deadline first. Means precedence is made the highest for a task that corresponds to an interrupt service which occurs at the earliest times and which deadline will finish earliest. So this is also called as earliest deadline first algorithm. So we will see here the diagram for cooperative round robin scheduling using a circular key, which is your first algorithm, where your task will be in the wait state to collect its data. Once it is over, then it will shift to the ready to run state, where your process will be in queue. So once your priority is assigned, means the highest priority task will be having the first priority for to be in the running state. So in this way there is a circular queue, and so it is also a cooperative round robin scheduling using a circular key of ready task. So this is your first algorithm. So next is your preemptive scheduling, where highest priority task will be in the running state or will be getting the CPU time first. So this is the way of assigning the priorities, which is static or dynamic. Then next algorithm is precedence assignment in scheduling algorithm, nothing but earliest deadline first. So it will calculate the time, and based on that priorities will be assigned, and then earliest deadline will be taken as a priority task. It computes priorities at arrival time. So formula is there for calculation of your CPU time. Thank you.